So picture this. You're at 30,000 feet, cruising smoothly above the clouds. But have you ever stopped to think about the invisible highways that are guiding your plane with absolute pinpoint accuracy? Well, today, we're pulling back the curtain on RNAV, the incredible system that makes modern air travel not just possible, but amazingly safe and efficient. You know, it's a question a lot of us have had while staring at the flight tracker on the seat back. Those gentle curves, they almost seem inefficient, right? But they're actually a clue that tells a really fascinating story about how aviation has evolved and how we went from just connecting the dots to literally drawing our own paths across the sky. So to really get why our modern system is so brilliant, we need to take a quick trip back in time. For decades, navigating the skies was kind of like a road trip before GPS. Pilots had to fly from one specific landmark to the next, literally hopping between ground-based radio towers that were their only signposts in the sky. And this really shows the difference. On the one hand, you've got the old way, a really rigid, zigzagging path that just wasted time and fuel. I mean, it worked, it was reliable, but it was far from perfect. And on the other hand, you have the modern method, area navigation, or RNAV. Think of it like a state-of-the-art GPS that can create the most direct, efficient route you can imagine, totally freeing the plane from being stuck to those old ground stations. Now, this new system, RNAV, it didn't just tweak navigation a little bit. No, it completely revolutionized how we use our airspace. It was the key that unlocked so much more efficiency, it helped reduce emissions, and it allowed for the safe, simultaneous movement of thousands of aircraft all at once. It was a total game changer. The real magic of RNAA is its flexibility. It lets a plane fly on literally any desired path without needing to be tethered to those ground stations. It creates this massive grid of virtual highways in the sky. And what does that mean? It means more direct routes, less air traffic congestion, and a much, much smarter use of the sky. Okay, but with all this newfound freedom, you've got to have some serious responsibility, right? You can't just have thousands of planes flying their own precise, invisible paths without an incredibly robust set of rules to make sure everyone stays exactly where they're supposed to be. And that's where these standards for precision come in. And this is a really crucial point. RNAV isn't just about what fancy equipment you have in the cockpit. It's a performance-based standard. The FAA, they care less about what tech you have and a lot more about how accurately that tech performs. It is all about results. So the first standard is RNAV1, and this is the gold standard for precision. What it means is the aircraft's entire navigation system has to keep it within 1 nautical mile of the route's centerline for 95% of the time. Now, 1 nautical mile, that's about 6,000 feet or the length of 20 football fields. This level of accuracy is absolutely essential when you're navigating the crowded skies near major airports. Then you've got RNAV2, which gives pilots a little more breathing room, 2 nautical miles. This standard is used when there's more open sky and aircraft are much farther apart. So you might be wondering, how do these different standards actually get used during a flight? While this table lays it out perfectly, the super precise RNAV1 standard is absolutely critical for the terminal phase. We're talking departures and arrivals, where planes are maneuvering really close to each other and the airport. But then, once the plane is up at cruising altitude, the system can switch to the more relaxed RNAV2 standard for the main en route part of the journey. It's just smart. So what's the magic behind this incredible accuracy? What are the brains of the operation? Well, it's not just one single black box. It's more like a sophisticated symphony of different technologies all working together in perfect harmony to know exactly where that aircraft is at every single moment. The main source is usually the GPS network, beaming down constant location data from satellites. But what if that signal gets weak or lost? That's where the brilliant backup systems kick in. Distance Measuring Equipment, or DME, uses radio signals from 2 different ground stations to triangulate the plane's position. And as a final, incredible failsafe, the Inertial Reference Unit, or IRU, is a self-contained marvel of engineering. It uses hypersensitive gyroscopes and accelerometers to track the plane's every move, completely independent of any outside signals. Okay, so we've got all this incredible redundant tech, but even the most advanced technology is only as good as the people who operate it. To keep millions of passengers safe every single day, there's a really rigorous process of approval and training that brings together the machine, the airline, and of course the pilots. Yeah, this isn't just about installing a new piece of hardware and calling it a day. The FAA treats RNAV as a complete system. The aircraft's equipment, the airline's operating procedures, and the flight crew's intensive training. All of it has to work together, seamlessly, to meet the absolute highest standards for safety.
And this four-step process just shows you how seriously they take it. First, the airline has to prove its planes have the right gear. Second, they have to create a detailed playbook for exactly how they're going to use it. Third, they develop a comprehensive training program to make sure their pilots are absolute experts. And only after the FAA has looked at every single detail do they get the green light to fly these advanced routes.
Because at the end of the day, with all this incredible automation going on, the pilots are the ultimate guardians of safety. They are the skilled human element that makes sure the system is working exactly as it should, and they're the ones prepared to take command in a split second if anything goes wrong. These pilots have to be complete masters of this complex system. Before every single flight, they've got to verify the navigation data is perfectly up to date. They need an intimate, deep understanding of how all the automated systems talk to each other. And crucially, they have to be ready to respond instantly to any new instructions from air traffic control or any unexpected system failures. They always have a plan B. So we've dived into the standards, the technology, the rigorous training. But what does all of this complex, behind-the-scenes work actually mean for you, the person sitting back in seat 17B? This quote from the FAA really gets right to the heart of it. The entire point of RNAV is to make the whole air travel system more efficient and, of course, safer. That means fewer delays for you, it means shorter flight times, less fuel burned, and a reduced workload for the pilots and air traffic controllers who are looking out for you. So the next time you're on a flight and you see that gentle, curved flight path on your screen, you'll know it's not a detour. It's actually a testament to this incredible system of technology, of exacting standards, and of human expertise, all working together in perfect harmony to create a hyper-efficient highway in the sky. RNAV is such a powerful reminder that our modern world is built on a foundation of these amazing, invisible systems. It really makes you wonder, doesn't it? What other marvels of engineering and human ingenuity are working just behind the scenes to make our lives easier and safer every single day?